Hi there, Minecrafters, and I have had a lot of questions in my last video about how to make redstone input into the Redpower 2 computers, and today I will show you how. A lot of people have also asked about the lights. I think it's this world. Nope. Maybe this world. Yes, these lights. And once again, well, you know why you get these blocks? That's when you mess around with the IDs. Anyway, here are the lights. And pay attention. You can see this is a green light, but basically it's just a ordinary big green glass light from Redpower 2. Let's see, it's one of these green lamp. So if I break it and place a mirror and place a block, you have the light, and you can just use any color. And you can see I just got a wire with a lever lighting them all up. Nothing special, and I don't see what's the fuss, because ever since there have been these lights in Redpower 2, you have been able to do this. Okay, that's done. Now I know for sure this is the second time recording it, and it is the second time showing it. But that's not important, and it's not fun. That's just design. Awesomeness, that's what we are going to work with today. And let's just get rid of these ridiculous blocks. There we go. So let's see, what have we? Alright. Well, I've made quite a few machinery, or new machines to show you. One of them is right there. In my last video I showed you this this farming, meat farming, and it wasn't so successful. Let's run it. Well, let's get some animals in there. There we go. Got some chicken and some pork pigs, and we type meat, and they all get pushed into the furnace. There we go. And when in there, they get burned. But if we look at the output, well, a feather, no meat. So I've been working on this. Well, this part you can see on my screen right now is just the spawner. I got a, let's see, a chicken spawner and a pig spawner. Get in there. And this is the farming machine, killing machine. What it does, it's basically push them into this area and they get squashed. And let's see, this is hooked up to two well, I can't remember their name, so let's look them up. IO expanders, of course, and one computer, one monitor, and a disk, as usual. And if you look carefully on the back, you can see one goes this way, one cable from the expander, and the other goes to the machine. And this is basically what people are asking for. I have connected a program to a button, so when I press this button, you can see the farm is running. First they get pushed in there, this area gets closed off, and they are suffocated. And this one is far more successful, as you can see. We get a lot more meat. And there's nothing special down here, just 3 transposers with Redpower tube, pneumatic tube to it. So, how does this work? Well, when you look at the screen, you can't type, you can hear me type, but nothing is showing. That's because a program is running in a loop. And I've made a simple example over here. I have 2 I/O expanders connected to one computer. One is when you shift right click, the I/O expander ID is 3 and the other is 4. So basically I read input on 3 and put output on 4. And well, let's run this program I have made before. And it's now running. So when I press the white one lights up over there. Orange lights up, and it goes through the computer. That's the point. And the last one over there is my break, because the program won't stop unless you add a break. So I added this one. And you can see it exits its loop. And if you look at the screen, you can basically see what I have done. Since we already know input is going in on 3, the I/O expander number 3, and going out on number 4. I first created 3 colors. The color white. So whenever I want the white light to lit up, the first thing I want to do is tell the program I want to connect to I/O expander number 4. That's this line, the first one. Then I want to power the white wire, because that's this one. Then I wait 25 ticks, that's a bit more than 1 second. Then I turn it off again. And then I reset it back to I/O expander number 3, because that makes it go back into listening mode, because the input comes from this one. You could use the same one. I just find it very easier, or more easier, to use 2 different. And I did the same with the different colors, orange and magenta. Now here's the program you run. As you can see, I called it main.program. You can call it anything. It won't come. Oh. And the first line you want to write is begin. Then you write the number it should check for, and the first number I check for is the color of the break, because I need to be able to exit the program before I test anything else. So that's the blue one, and that's number 8, if you remember from the last video. So the first thing I write is 8 IOX, and that's a I can't even remember the name in English. It's the letter you use when you write emails. The @ sign. Instead of the exclamation mark, you use the @ sign. Then equal. If, that basically means if this one is pressed, do this, and what it's going to do is exit. That means it will kill this program and go back into the next line. Then you write then, because from this point where it says 8 to then is basically use one command or one line. And then we check for the white, the same thing. If 1 is pressed, then we want to run the program white, and it will go up here and run this through, go back down. Then 2, check for 2 if that's lit. If not, then 4, check for 4. And I end the program with a small pause, else you would have your system, well, might overload, because some computers are able to run this program extremely fast. And you press again, or type again, and end the program. That means the program between begin and again will run forever until you press number 8. Don't worry, I will be building this step by step in a moment and going through every line. And when you do this, you could basically do like I have it here. I have just written a series. Well, let's end the program. There we go. And you can see, now it wrote the letters I typed before. As you can see, I have new words here. I always use small letters because the existing ones are capital letters. So I got the main program, which is the loop. Then I got something called meet, get, release, kill, up, down, untrap, trap, back, forward. That's basically just the functions of the machinery. Example, trap, that's a combination of forward and back. Well, just forward, it moves 8 forward, that's the trap. And untrap is back. Kill is a series of down motions, and release is a series of up motions. Get is powering the pneumatic pipe so you get the loot into the chest. And when you combine all of these, I wrote it into something called meet. And all of this I combined into this loop, as you can see here. This is my loop for my meat farm. As you can see, it says begin. Then it checks for button press on the white wire. If there is a button press, then it's going to switch to the other I/O expander and send the command meet or program, which is down here. Once meet is done, it's going to wait almost an entire second. Then it's going to switch back to the third I/O expander, or the first. Its number is just 3. And then it's going to keep checking if I'm pressing 1 or 2. So it's basically just standing here waiting, nothing's happening until you press the button. So, and another thing, suffocation is much more efficient when dealing with killing chicken and pigs. At least in Minecraft. And I've made another program here, as you remember, tree farm, wheat farm, yada yada. This one, underground. Okay, I need to start the program. As you can see, in this area I just call my program main. So now it's running. I press this button. And it's running. Just had a sip of water, there we go. We're getting wood. And back into the ground. There we go. As you can see, it still needs a few adjustments. It's leaving 1 block up there. That's easy to fix. And the wood ends up in this chest, as you can see. Basically, it's just like the other farm, except it's underground. This is the extension. Instead of adding a block breaker and a deploying each move, I thought it would be just as fun just to have one large piece of machinery going into the ground. It looks more impressive. And basically we just have the movement mechanics in there. You can see one of the machines there, and the other there. That's the up-down motion. And the power is right there, powering the redstone pneumatic pipe. The purple one is deploying bone meal. This piston is pushing the dirt forward, so this one are able to plant on the dirt, and once the bone meal has been applied, this one pulls the dirt back, so there's nothing below the tree. And it's all controlled by this computer and these two I/O expanders. This button here stops the program. Backup disk. And this I/O expander is for my input. This I/O expander is for my output to the machinery. So that's basically how you can set up a input-output device. And that's fun. That's fun, yeah. Okay. Time to set up a new device, and well, let's do it right here in this area here. Going through them step by step. So if you got it by now, no need to watch any further. I'm not sure if I'll have anything new at the end of the video, but right now I will start creating this new. Well, the example is going to be a program run by pressing a button. So let's get into it. First thing we need are, well, we're going to use two I/O expanders, one monitor, one CPU, one disk drive, and we need one blank floppy, one operating system, and a chest to begin with. So basically we're going to set up a CPU, monitor, disk drive. Then we want, what do we want? We want a cable to connect the I/O expanders. There we go, ribbon cable. So let's imagine we're going to place our buttons over here, and we're going to have our functions over there. So let's place one I/O expander there. Oh, that's bad. There. And the other one. Oh, well, you could place them on top of each other. And let's just hook them up. The main thing when you have two I/O expanders is to make sure you control the bus IDs. Since we already know or have planned, this one is for my input and this one is for my output. And yes, if you have simple functions or just something that uses less than 16 input and outputs, you can use only one, or you only need one. This one can handle both in and output, no worries. I'm just retarded that way. I love a lot of switches and functions. Take my screwdriver, and this is the sonic screwdriver, and this one is already ID3, so is this one, but we want it to be ID4. So we're going to turn this one off and this one off and that one on, and we have ID number 4. And we're set. This chest is to hold my operating system. It's a, well, I need something to put my disks in. Anyway, operating system in, start the computer. Yes, out, in with my disk. Operating system in the chest. Save. All. So basically everything is on the disk now. Alright. Now what should we build? Well, how about something that moves and lights up? What do we have? Yellow. So for that we also need some solar power, bat box, and we need some cable. So first I'm going to hook up the sun power because it's going to be a while before there's enough. And yes, I do know you can connect them directly to each other, but I don't like that. Deal with it. Apparently a lot of people are sending me both private tells and stuff about how these things can connect directly to each other, and I'm quite aware of that, but it's just I prefer it this way. And since I'm using NEI, I don't really care. Okay, now we want something moving, so should we have it moving up and down, or back and forth, or both? Well, first, oh, I need a cable. Well, let's just have it moving back and forth. So, one there, one there. So we have something that can move back and forth. Yeah. And a stone. Now one of the new wood planks. There we go. That's our buffer, so 1, 2, 3 is how far it can move. There we go. 3 in both directions. Just to make sure it's not going to stick to the wall. Well, doesn't really matter. It will just pull it out. So that's motion. Let's get it powered up. That might not have been so good. 1, 2, 3. Oops. That's better. If this one moves 3, this one moves 3. 1, 2, 3. Okay, let's just imagine it will work. There we go. And we also want a light. Where do we get something amazing? There we go. Whew. And we have a light. Now we want some daylight. Thank you. Let's hook all of this up to the computer. And now you need to use your imagination and imagine this could be some sort of factory or complicated process you're building. And since we're using 1, 2, 3 functions, I'm just going to use the first 3 cables. 1, 2, 3. And since I need to remember this by heart, or write it down on a piece of paper, what you usually say is from left to right. So left is first. Left was the first thing I said, so left to right. And some flashing. There we go. That's wrong. And we're basically done with these cables. Now we just need a cable bunch. Let's use a white bunch. There we go. And you're done. Ta-da! That was easy. Well, now we want to hook up the input and output of this. And I'm going to hook it up on these blocks of iron. And I need 2 signals. I need one to start the process. And that's going to be the white one. And I need one to stop everything, so that's going to be the orange. And I just want to add a button. Let's see if they work. Yes, this one works. This one works. And now we have everything set up. So the next thing to do is have these small functions actually do something, and for that we're going to use the program. So let's start with the most simple thing, the yellow light, and that's on cable number 3. So if we remember our binary code, it goes 1, 2, 4, so that's number 4. Let's test it for IOX, and we failed miserably because we didn't switch our IO expander, as you can see there. It's outputting on 3 and it should output on number 4. Oops. 0 IOX. So to switch the IO expander, I'm going to switch to IO expander number 4 and IOX ADDR. That means use IO expander number 4 from now on. So for IOX, and the yellow light is on, and you can see it's lighting on this one instead of this one. Woohoo! I'm going to celebrate with a sip of water. Very nice. Let's turn that light off again. Now we know that number 4 is the light, so let's create a small word called light. And what it does, it's turning on the number 4. Well, as you can see, I'm switching the IO expander within the command light. That's important to notice so you don't use an excess of these commands. So I am pulling the IO expander switch into each command so I don't have to worry about them later. And I'm just going to leave it on 3. Notice that, please. So first IO expander number 4, turn light on with this command. And since we're going to have it to flash, we're going to turn it off after 15 ticks. There we go. And 0 IOX to turn it off. And we need to give it a wait signal not to crash. And then, because we switched to IO expander number 4, we need to switch back to IO expander number 3. End program. So, in the main, well, let's call it DOS, main OS, MOS, I'm going to switch to IO expander number 3. So basically when I type IOX1, this one will lit up. But when I type light, as you can see here in the edge of the monitor, it's automatically going to switch to that one. So I don't have to worry about the switching. That's great. Okay, now since we're going to move these, and we know 1 is moving this one left and 2 is moving this one right, we're going to make left and right commands. Left and move IO expander again, and we're going to move it with the white cable. We're going to turn it off after 15 ticks, as usual, and a short wait, and switch back to IO expander number 3. So, as you can see over here, flashing my mouse, if I type left, it should move left. It works. Now let's make the same right command, but with the number 2 instead of 1. 6, 0 IOX, 5, 6, 3 IOX AV 1. Right, and it works. And since I have these two wooden blocks, there is a natural limit, because once they hit this block here, they can't move any further. So, nothing to worry about. And when they hit this wall, this top one is going to stick to this one, but that's just fine. Okay, so what do we actually want this program to do? Well, first thing I want to do is make this one move 3 times to the left, and then flash 2 times with the light, then 3 times to the right, flash 2 times with the light, and back to center. Okay, let's do that. For that I'm going to write, well, usually you would call it a function, but we're still working in words here, so let's call it movement. First thing I want to do is move the damn thing 3 times left, so I'm going to write 3, 0, do, left, loop. And if you remember my last video, this is a do loop. You start with 0, move up to 3, and you do left that amount of times. Once you're there, you want to flash 2 times. Do, 0, do, what did we call it? We call it light, loop. Okay, then we want to move it 3 times to the right, but that would just place it at the center. If you move this on 3 times to the left, 3 times to the right, it would be the basic or the initial state, so instead we're going to go 6 times to the right. Yabba yabba yabba. And we're going to flash the light twice again. Okay, and then we want to reset it, so that's 3, 0, do, left, loop again. So it will be reset at the center position. And flash the light once, so we're just going to type light. End program. There we go. And let's test it. Movement 1, 2, 3, flash, flash. Oh yeah. And it's going to reset itself. Amazing. I'm almost impressed. So now we want these buttons to work, and let's see, where's the sign? Oh, we're just going to use color coordination. So let's see, this one is going to start it, this one is going to stop the program. And since it's the white, we're going to write a input program. But before that, we're going to type save, random name, wait it, and it's on the disk, just in case. Sometimes I do fuck these up, and I have to press the reset button on the computer and all your commands are lost. That is shit. What should we call it? Main lols. There we go. So, as we already know, this one is listening on IO expander number 3 for input. So we're going to type begin. And the first thing we want to do is check for the break signal. I want to be sure that I can stop the programs at all times. So we are going to recheck the colors, and this is orange, that's number 2. So I'm going to type to IOX at sign equal sign if, that means if 2 is pressed, then exit. And even though it now knows it's going to exit, we still have to type then because we're not done. But this basically enables us to break the program at any time. Yes, great achievement. So now we want to check for the white wire if it's going to be pressed. So that's number 1, IOX at sign equal sign if 1 is pressed, then run the program movement. Okay, and wait a short while, then. So basically now we have both buttons hooked up. Now we just need to reset the cycle. We're going to wait just a bit so we don't crash anything. 5 ticks is basically nothing. And then we're going to set again, which means start over, and end the program. Save all. And we're going to run main logs. There we go, and as you can see, it doesn't end, which means it's listening over here. So if I press this, the function is working. Flash, flash, move, move. It's not going to interrupt the program when you click stop. But if you want to add more or do anything else, you have to be able to stop it. So by clicking that one, you get a new line. And that's basically how you enable input through a computer to do something output. So you could add a elevator or something with different floors and have a computer in the basement hidden somewhere, and the user would never see it. They just see the button, so when they press the button, the elevator would move to that floor, blink a light or something, press another button and move to something else. Just like this over here. I can't remember if the program is running. The only problem is if the program stops. You can't start a program by pressing a button. So you need someone to go back in and start the program. But the reset or stop button shouldn't be shown to people. It should be hidden away somewhere near the computer, of course. There we go. Killing chickens. Thanks for watching, guys. Hope you enjoyed. And as usual, if you have suggestions, lol. If you have a suggestion, let me know in the comment section. Subscribe, rate, and remember, Minecraft is for fun, it's entertainment. See you in the next one. Bye.